Welcome, everyone, to this tranquil exploration of the quantum realm, where we'll delve into the fascinating world of quantum optics and photonics. Tonight, we're going to unravel the mysteries of single photons, those individual particles of light, and discover how they can carry information in ways that seem almost magical, all while maintaining a peaceful, almost silent existence. Prepare to be lulled into a state of serene curiosity as we uncover the secrets of light. Imagine, if you will, the vast expanse of the universe, filled with countless stars, galaxies, and nebulae. Each of these celestial bodies emits light, and that light is composed of photons. Now, zoom in, far in, until you can perceive a single photon. This tiny packet of energy is the fundamental unit of light, and it behaves in ways that defy our everyday intuition. It's both a particle and a wave, existing in a state of quantum superposition until we try to measure it. This duality is at the heart of quantum mechanics, and it's what allows photons to perform such extraordinary feats. So, what exactly is quantum optics? It's the branch of physics that studies the interaction of light with matter at the quantum level. It explores phenomena like photon entanglement, quantum superposition, and quantum coherence. These concepts might sound complex, but we'll break them down into digestible pieces, using analogies and visualizations to help you grasp the underlying principles. Think of it as a gentle journey through the landscape of light, where each step reveals a new and wondrous vista. And what about photonics? Photonics is the technology of generating and harnessing light and other forms of radiant energy whose quantum unit is the photon. Photonics includes topics such as light emission, transmission, amplification, detection, and modulation. So, while quantum optics explores the fundamental physics of light, photonics focuses on the practical applications of that knowledge. It's the engineering side of the quantum light story, where scientists and engineers are working to build new technologies that harness the unique properties of photons. This includes everything from advanced sensors and imaging systems to quantum computers and secure communication networks. Imagine a future where information is transmitted via single photons, making it virtually impossible to eavesdrop on communications. This is the promise of quantum cryptography, and it's one of the many exciting applications of photonics. Now, let's focus on single photons. These are the individual packets of light that we've been talking about. They're the smallest units of light that can exist independently, and they have some remarkable properties. One of the most intriguing is their ability to carry information. But how can a single particle of light carry information without making a sound? The answer lies in the quantum properties of photons, specifically their ability to be polarized. Polarization refers to the orientation of the electric field of a photon. Think of it as the direction in which the photon is vibrating. Photons can be polarized vertically, horizontally, or at any angle in between. This polarization can be used to encode information, much like the ones and zeros in a digital computer. Imagine a stream of photons, each polarized in a specific direction. by assigning a different meaning to each polarization state, we can encode a message in the stream of light. For example, we could say that a vertically polarized photon represents a 1, while a horizontally polarized photon represents a 0. In this way, we can transmit information using nothing but individual particles of light. But the real magic happens when we start to exploit the quantum properties of photons, such as superposition and entanglement. Superposition, as we touched on earlier, is the ability of a quantum system to exist in multiple states at the same time. A photon, for example, can be in a superposition of vertical and horizontal polarization. It's as if the photon is both vertically and horizontally polarized simultaneously, until we try to measure its polarization. This might seem strange, but it's a fundamental feature of quantum mechanics, and it has profound implications for how we can use photons to carry information. Entanglement is another mind-boggling quantum phenomenon. When two photons are entangled, their fates are intertwined, no matter how far apart they are. If we measure the polarization of one photon, we instantly know the polarization of the other, even if they are separated by vast distances. This connection is instantaneous and doesn't involve any physical signal traveling between the photons. Einstein famously called it spooky action at a distance. So, how can we use entanglement to carry information? Imagine we have two entangled photons, and we send one photon to Alice and the other to Bob. Alice can then manipulate her photon in a certain way, and Bob will instantly see the effect on his photon, even though there's no physical connection between them. This allows Alice and Bob to perform tasks that would be impossible with classical physics, such as quantum teleportation and quantum key distribution. Quantum teleportation, despite its name, doesn't involve teleporting matter. Instead, it's a way to transfer the quantum state of one photon to another, using entanglement as a resource. Quantum key distribution, on the other hand, is a way to generate a secret key between two parties with a security guaranteed by the laws of physics. This is because any attempt to eavesdrop on the quantum communication will inevitably disturb the entanglement, alerting Alice and Bob to the presence of an eavesdropper. Let's delve a little deeper into quantum key distribution, or QKD. This is a cryptographic protocol that allows two parties, typically called Alice and Bob, to produce a shared random secret key known only to them, which can then be used to encrypt and decrypt messages. The security of QKD relies on the fundamental laws of quantum mechanics, specifically the uncertainty principle and the no-cloning theorem. The uncertainty principle states that certain pairs of physical properties, such as position and momentum, cannot both be known with perfect accuracy. The no-cloning theorem, on the other hand, states that it is impossible to create an identical copy of an arbitrary, unknown quantum state. These two principles together ensure that any attempt to eavesdrop on the quantum communication will inevitably introduce detectable disturbances. One of the most well-known QKD protocols is the BB84 protocol, named after its inventors Charles Bennett and Gilles Broussard. In this protocol, Alice sends Bob a series of photons, each polarized in one of 4 possible directions: 0 degrees, 45 degrees, 90 degrees, or 135 degrees. Alice chooses the polarization randomly for each photon. Bob then measures the polarization of each photon using a randomly chosen basis. He either uses a rectilinear basis, 0 degrees and 90 degrees, or a diagonal basis, 45 degrees and 135 degrees. After Bob has measured all the photons, he and Alice publicly compare their bases. For the photons where they use the same basis, they keep the results. For the photons where they use different bases, they discard the results. The remaining results form a shared secret key, which can then be used to encrypt and decrypt messages. If an eavesdropper, typically called Eve, tries to intercept the photons and measure their polarization, she will inevitably introduce errors into the communication. This is because Eve doesn't know which basis Alice used to prepare the photons, so she has to guess. If she guesses correctly, she can measure the polarization without introducing any errors. But if she guesses incorrectly, she will disturb the polarization of the photon, introducing an error. By comparing a subset of their key, Alice and Bob can estimate the error rate. If the error rate is below a certain threshold, they can be confident that the communication is secure. If the error rate is above the threshold, they discard the key and start over. Now, let's shift our focus from quantum key distribution to another fascinating application of single photons: quantum computing. Quantum computers are a new type of computer that exploit the principles of quantum mechanics to perform calculations that are impossible for classical computers. While classical computers store information as bits, which can be either 0 or 1, quantum computers store information as qubits, which can be in a superposition of 0 and 1. This allows quantum computers to perform many calculations simultaneously, making them potentially much faster than classical computers for certain types of problems. Single photons can be used to create qubits. The polarization of a photon, for example, can represent a qubit. A vertically polarized photon can represent the state 0, while a horizontally polarized photon can represent the state 1. A photon in a superposition of vertical and horizontal polarization can represent a qubit in a superposition of 0 and 1. These photonic qubits can then be manipulated using optical elements, such as beam splitters and mirrors, to perform quantum computations. One of the challenges in building quantum computers is maintaining the coherence of the qubits. Coherence refers to the ability of a qubit to maintain its superposition state. When a qubit loses coherence, it collapses into a classical state of either 0 or 1, and the quantum computation is ruined. Photons are particularly well suited for quantum computing because they are relatively immune to decoherence. This is because photons interact weakly with their environment, which means that they are less likely to be disturbed by external noise. However, photons also have their challenges. One of the biggest challenges is creating strong interactions between photons. Quantum computations require qubits to interact with each other, and it is difficult to make photons interact strongly because they are electrically neutral. Scientists are exploring various ways to overcome this challenge, such as using nonlinear optical materials or trapping photons in cavities. Beyond quantum computing and quantum key distribution, single photons are also finding applications in a variety of other fields, such as quantum imaging, quantum sensing, and quantum metrology. Quantum imaging uses the quantum properties of light to create images with higher resolution or sensitivity than classical imaging techniques. For example, quantum imaging can be used to image objects that are hidden from view or to create images with very low levels of light. Quantum sensing uses the quantum properties of light to create sensors that are more sensitive than classical sensors. For example, quantum sensors can be used to detect very weak magnetic fields or to measure very small changes in temperature. Quantum metrology uses the quantum properties of light to make measurements with higher precision than classical metrology techniques. For example, quantum metrology can be used to measure the distance between two objects with very high accuracy or to measure the frequency of a laser with very high precision. The study of single photons and their applications is a rapidly evolving field, with new discoveries and innovations being made all the time. As we continue to unravel the mysteries of light, we can expect to see even more amazing applications of single photons in the future. From secure communication networks to powerful quantum computers, the potential of single photons is truly limitless. And as you drift off to sleep tonight, consider the incredible journey we've taken together, exploring the quantum world of light. Think about the tiny packets of energy that are all around us, carrying information and enabling new technologies. And remember that even the smallest things can have a profound impact on the world. As you close your eyes, imagine yourself floating in a sea of photons, each one a tiny messenger of the universe, whispering secrets of quantum mechanics. Let the gentle hum of quantum physics lull you into a peaceful and restful sleep. Sweet dreams, and may your mind be filled with the wonder of science. Now, let's pivot our attention to the practical aspects of generating and detecting single photons. Creating and manipulating these elusive particles is no easy feat, requiring sophisticated experimental setups and techniques. One common method for generating single photons is through a process called spontaneous parametric downconversion, or SPDC. In SPDC, a high-energy photon is sent into a special nonlinear crystal where it spontaneously splits into two lower-energy photons. These two photons are entangled, meaning their quantum states are correlated. By carefully controlling the properties of the crystal and the input photon, scientists can ensure that the downconverted photons are emitted as single photons. Another technique for generating single photons involves using quantum dots. Quantum dots are tiny semiconductor nanocrystals that exhibit quantum mechanical properties. When a quantum dot is excited by a laser, it can emit a single photon as it returns to its ground state. Quantum dots are particularly attractive for single photon generation because they can be easily integrated into solid-state devices. Detecting single photons is equally challenging Because single photons carry so little energy, they're difficult to detect with conventional detectors. One common type of single photon detector is the avalanche photodiode, or APD. APDs are semiconductor devices that can detect single photons by amplifying the signal produced by the photon. When a photon strikes the APD, it triggers an avalanche of electrons, creating a large current pulse that can be easily detected. Another type of single photon detector is the superconducting nanowire single photon detector, or SNSPED. SNSPEDs are made from superconducting materials that are cooled to extremely low temperatures. When a photon strikes the SNSPED, it breaks the superconductivity, creating a voltage pulse that can be detected. SNSPEDs are among the most sensitive single photon detectors available, but they require cryogenic cooling to operate. Once single photons have been generated and detected, they can be manipulated using a variety of optical elements, such as beam splitters, mirrors, and wave plates. Beam splitters are used to split a beam of light into two beams, while mirrors are used to reflect light. Wave plates are used to change the polarization of light. By carefully arranging these optical elements, scientists can create complex optical circuits that can perform quantum computations or implement quantum communication protocols. For example, a Mach-Zehnder interferometer, which consists of two beam splitters and two mirrors, can be used to create superpositions of photons. When a single photon is sent into the interferometer, it is split into two paths by the first beam splitter. The photon then travels along both paths simultaneously, creating a superposition of being in both paths at once. The two paths are then recombined by the second beam splitter, and the photon is detected at one of the two output ports. The probability of detecting the photon at each output port depends on the relative phase of the two paths, which can be controlled by adjusting the mirrors in the interferometer. The field of quantum optics and photonics is not without its challenges. One of the biggest challenges is scaling up quantum systems. Many of the quantum technologies we've discussed, such as quantum computers and quantum communication networks, require large numbers of qubits to operate effectively. However, creating and controlling large numbers of qubits is extremely difficult. As the number of qubits increases, the complexity of the system grows exponentially, making it harder to maintain coherence and control errors. Another challenge is developing practical applications for quantum technologies. While quantum technologies hold great promise, many of them are still in the early stages of development. It will take time and effort to translate these technologies from the laboratory to real-world applications. This requires not only technological advances, but also new business models and regulatory frameworks. Despite these challenges, the field of quantum optics and photonics is making rapid progress. New discoveries and innovations are being made all the time, and the potential of quantum technologies is becoming increasingly clear. As we continue to explore the quantum world of light, we can expect to see even more amazing applications of single photons in the future. And as you continue to relax and prepare for sleep, consider the profound implications of these discoveries. The ability to control and manipulate single photons opens up a whole new world of possibilities, from secure communication to powerful computation to advanced sensing and imaging. As you drift off to sleep, let your mind wander through the quantum landscape, where the laws of physics are turned on their head and the seemingly impossible becomes reality. Imagine yourself as a photon, traveling through space and time, carrying information and connecting distant parts of the universe. Let the gentle glow of quantum light guide you into a peaceful and restful sleep. Pleasant dreams, and may your subconscious be filled with the wonders of quantum science. Now, let's consider the broader implications of quantum optics and photonics for our understanding of the universe. The study of light has always been central to physics, from Newton's experiments with prisms to Einstein's theory of relativity. Quantum optics and photonics are taking this exploration to a new level, revealing the fundamental nature of light and its interactions with matter. One of the most profound implications of quantum optics is its connection to the concept of quantum entanglement. As we discussed earlier, entanglement is a phenomenon in which two or more particles become linked together in such a way that they share the same fate, no matter how far apart they are. This connection is instantaneous and doesn't involve any physical signal traveling between the particles. Einstein famously called it spooky action at a distance, because it seemed to violate his theory of relativity, which states that nothing can travel faster than light. However, numerous experiments have confirmed the existence of entanglement, and it is now considered to be a fundamental feature of quantum mechanics. Entanglement has profound implications for our understanding of reality. It suggests that the universe is not made up of separate, independent objects, but rather that everything is interconnected in some way. This interconnectedness is not limited by space or time, meaning that two entangled particles can be linked together even if they are separated by billions of light years. This raises deep philosophical questions about the nature of reality, causality, and the role of observation in shaping the universe. Quantum optics and photonics are also shedding light on the nature of quantum measurement. In classical physics, measurement is a passive process that simply reveals the properties of an object without affecting it. However, in quantum mechanics, measurement is an active process that can fundamentally change the state of a system. When we measure a quantum system, we force it to choose one particular state out of a range of possibilities. This process is known as wave function collapse, and it is one of the most mysterious and controversial aspects of quantum mechanics. Quantum optics and photonics are providing new insights into the process of quantum measurement. By studying how photons interact with detectors, scientists are gaining a better understanding of how measurement affects the quantum state of light. This research is not only helping us to understand the foundations of quantum mechanics, but also leading to new technologies, such as quantum sensors that can measure extremely weak signals without disturbing them. As we delve deeper into the quantum world of light, we are uncovering new layers of complexity and mystery. The more we learn, the more we realize how much we don't know. But this is what makes science so exciting. It is a never-ending quest to understand the universe and our place within it. And as you continue to relax and prepare for sleep, I encourage you to embrace the mystery and the wonder of quantum physics. Let your mind be open to new possibilities and new ways of thinking about the world. As you drift off to sleep, imagine yourself as a quantum explorer, venturing into the unknown and discovering new truths about the universe. Let the gentle hum of quantum physics lull you into a peaceful and restful sleep. Sweet dreams, and may your mind be filled with the wonder of science. Now, let's turn our attention to the ethical considerations surrounding quantum optics and photonics. As with any powerful technology, quantum technologies have the potential to be used for both good and evil. It is important to consider the ethical implications of these technologies and to ensure that they are used responsibly. One of the biggest ethical concerns surrounding quantum technologies is the potential for misuse in the area of surveillance and espionage. Quantum key distribution, for example, could be used to create unbreakable communication networks, which could be used by governments or criminal organizations to hide their activities from law enforcement. Quantum sensors could be used to create highly sensitive surveillance devices that could be used to spy on individuals without their knowledge or consent. It is important to develop safeguards to prevent the misuse of these technologies and to ensure that they are used in a way that respects privacy and civil liberties. Another ethical concern is the potential for quantum technologies to exacerbate existing inequalities. Quantum computers, for example, could be used to develop new drugs and materials, but these benefits may not be equally accessible to everyone. If quantum technologies are only available to the wealthy and powerful, they could widen the gap between the haves and have-nots. It is important to ensure that the benefits of quantum technologies are shared equitably and that everyone has access to these technologies, regardless of their socioeconomic status. In addition to these ethical concerns, there are also environmental considerations to keep in mind. Quantum technologies often require rare and expensive materials, such as superconducting materials and nonlinear crystals. The extraction and processing of these materials can have significant environmental impacts. It is important to develop sustainable practices for the production and use of quantum technologies to minimize their environmental footprint. As we continue to develop quantum technologies, it is crucial to consider the ethical and environmental implications of these technologies. We must ensure that these technologies are used responsibly and that their benefits are shared equitably. This requires a collaborative effort involving scientists, engineers, policymakers, and the public. By working together, we can ensure that quantum technologies are used to create a better future for all. And as you continue to relax and prepare for sleep, I encourage you to reflect on these ethical considerations. Think about the role that technology plays in our society and the responsibility that we all have to use technology in a way that benefits humanity. Let your mind be open to new ideas and new perspectives on these important issues. As you drift off to sleep, imagine yourself as a responsible steward of technology, working to ensure that quantum technologies are used for the good of all. Let the gentle hum of quantum physics lull you into a peaceful and restful sleep. Sweet dreams, and may your mind be filled with the wisdom and compassion to use technology wisely. And as you gently transition into sleep, consider the sheer elegance of the quantum world we've explored. The very fabric of reality, woven with threads of light, behaving in ways that challenge our everyday intuition. These aren't just abstract concepts confined to laboratories. They're the fundamental principles governing the universe around us. Principles that are now within our grasp to manipulate and harness. Think about the implications of perfectly secure communication, unbreakable codes whispered across the quantum realm, safeguarding our most sensitive information. Imagine sensors of unparalleled precision, capable of detecting the faintest signals, revolutionizing medical diagnostics and environmental monitoring. The journey into quantum optics and photonics is a journey into the heart of possibility. It's a realm where the seemingly impossible becomes reality, where the boundaries of what we can achieve are constantly being pushed. But with this power comes responsibility. The ethical considerations we discussed are not mere afterthoughts. They are integral to the development and deployment of these technologies. We must strive to ensure that quantum technologies are used to empower, not to divide, to heal, not to harm. As you drift deeper into slumber, contemplate the beauty of superposition. A single photon existing in multiple states simultaneously, a metaphor for the vast potential that lies within each of us. We too are capable of holding multiple perspectives, of exploring different possibilities, of embracing the complexity of the world around us. Just as a photon collapses into a single state upon measurement, we can focus our energy and intention to manifest our goals and aspirations. Let the knowledge of quantum entanglement soothe you. Two photons inextricably linked, their fates intertwined, even across vast distances. This speaks to the interconnectedness of all things, the profound relationships that bind us together. We are all part of a larger whole, and our actions have ripple effects that extend far beyond our immediate surroundings. And finally, as you slip into the embrace of sleep, remember the wave-particle duality of light, sometimes behaving as a wave, spreading out and interfering, other times as a particle, discrete and localized. This duality reminds us that reality is not always what it seems, that there are hidden layers of complexity waiting to be discovered. Embrace the uncertainty, the ambiguity, and the mystery of the universe, for it is in these spaces that true innovation and understanding can flourish. Allow the gentle rhythm of your breath to synchronize with the subtle vibrations of the quantum world. Feel the interconnectedness of all things, the potential for limitless possibilities, and the responsibility that comes with wielding such power. Sleep soundly, knowing that you are part of a universe that is both wondrous and awe-inspiring. And may your dreams be filled with the light of knowledge and the wisdom of compassion. Good night, and as you rest, consider the implications of quantum key distribution. Imagine a world where information is exchanged with absolute security, unhackable and impervious to eavesdropping. This isn't science fiction. It's a tangible reality being built upon the principles of quantum mechanics. The very act of attempting to intercept a quantum key alters it, alerting the intended recipients to the presence of an eavesdropper. This inherent security, guaranteed by the laws of physics, promises to revolutionize communication and protect our most sensitive data. Visualize this secure flow of information, a silent river of light, safeguarding secrets and fostering trust in a digital age often plagued by uncertainty. Think also about the potential of quantum computing, powered by the manipulation of individual photons. These machines, still in their infancy, hold the promise of solving problems that are intractable for even the most powerful classical computers. Imagine designing new drugs and materials, optimizing complex systems, and breaking seemingly unbreakable codes, all thanks to the peculiar properties of light at the quantum level. It's a future where the impossible becomes possible, where the boundaries of human knowledge are constantly pushed further by harnessing the power of the quantum realm. Picture these quantum computers humming softly, processing information in ways that defy our classical intuition, unlocking new frontiers of scientific discovery. Furthermore, let your mind wander to the realm of quantum sensors. These devices, utilizing the exquisite sensitivity of photons to their environment, can detect the faintest of signals, revealing hidden realities that would otherwise remain invisible. Imagine using quantum sensors to image the human brain with unprecedented resolution, to detect trace amounts of pollutants in the atmosphere, or to navigate with unparalleled accuracy. This technology promises to revolutionize fields ranging from medicine to environmental science to navigation, providing us with new tools to understand and interact with the world around us. Envision these sensors silently and invisibly gathering data, revealing the subtle nuances of the universe that surround us. And as you continue to relax, consider the role of quantum photonics in the development of new energy technologies. Imagine harnessing the power of sunlight with unprecedented efficiency, converting it directly into electricity with minimal loss. Quantum materials and devices are being designed to capture and manipulate photons in ways that could revolutionize solar energy, providing us with a clean and sustainable source of power for generations to come. Picture vast arrays of quantum solar cells silently and efficiently converting sunlight into energy, powering our homes and cities with clean, renewable energy. Finally, as sleep gently claims you, remember that the journey into the quantum realm is a journey of continuous discovery. There is still much that we don't understand about the nature of light and its interactions with the world around us. But with each new experiment, with each new theoretical breakthrough, we are slowly unraveling the mysteries of the quantum universe. Embrace the unknown, the uncertainty, and the endless possibilities that lie ahead. Let the pursuit of knowledge be a guiding light in your life, illuminating the path towards a brighter future. Sleep now and dream of the wonders that await us in the quantum world. Let the gentle hum of the universe lull you into a peaceful and restorative slumber. Good night, and may your dreams be filled with light. And as you drift further into relaxation, let's consider one final fascinating aspect of quantum photonics: its potential to revolutionize the world of computing. Traditional computers store information as bits, which are either a 0 or a 1. Quantum computers, however, leverage the principles of quantum mechanics to store information as qubits. A qubit can exist in a superposition of states, meaning it can be both a 0 and a 1 simultaneously. This allows quantum computers to perform calculations that are impossible for even the most powerful classical computers. Photons, with their ability to exist in multiple states at once, are excellent candidates for carrying qubits. Imagine a future where incredibly complex problems, such as drug discovery or materials design, can be solved in minutes, thanks to the power of quantum photonic computers. Envision these computers humming with quantum activity, unlocking secrets of the universe, and driving innovation in countless fields. Think about the implications for cryptography. Current encryption methods rely on mathematical problems that are incredibly difficult for classical computers to solve. However, quantum computers, with their unique computational abilities, could potentially break these codes. This has spurred the development of quantum cryptography, which uses the principles of quantum mechanics to create unbreakable codes. Quantum key distribution, for example, uses single photons to transmit encryption keys in a way that is inherently secure. Any attempt to intercept the photons would disturb their quantum state, alerting the sender and receiver to the eavesdropping attempt. Picture a world where communication is completely secure, protected by the laws of quantum physics. Consider the possibilities for advanced imaging techniques. Quantum entanglement, a phenomenon where two photons become linked together regardless of the distance separating them, can be used to create images with unprecedented resolution. By entangling photons and using them to illuminate a sample, scientists can overcome the limitations of classical imaging techniques. This could lead to new ways of visualizing biological structures, identifying diseases, and exploring the universe. Imagine seeing the world with a level of detail that was previously unimaginable, revealing hidden structures and processes with stunning clarity. And as you feel yourself drifting closer to sleep, remember that the study of quantum optics and photonics is not just about understanding the fundamental laws of nature. It's also about harnessing those laws to create new technologies that can improve our lives and solve some of the world's most pressing challenges. From quantum sensors to quantum computers to quantum cryptography, the possibilities are endless. Allow yourself to be filled with a sense of wonder and excitement about the future. Let your mind wander through the quantum landscape, imagining the breakthroughs that are yet to come. Picture the next generation of scientists and engineers building upon the knowledge that we have gained and pushing the boundaries of what is possible. Know that you are a part of this journey, even in your dreams. Now, Release any remaining tension in your body. Let your breath become slow and deep. Focus on the gentle rise and fall of your chest. Allow the soothing sounds of my voice to fade into the background. Let go of all thoughts and worries. Simply be present in this moment. Sleep deeply and peacefully, knowing that the universe is filled with wonder and mystery. Tomorrow, you will wake up refreshed and ready to explore the world with new eyes. Good night, and may your dreams be filled with the gentle glow of photons. Sweet dreams. As you continue to relax, consider the potential of single photon sources. Imagine tiny devices meticulously crafted that emit just one photon at a time on demand. These aren't just theoretical concepts. They're becoming a reality. Scientists are developing sophisticated techniques to create these single photon sources using materials like quantum dots and nanoscale structures. These sources are essential for many quantum technologies, acting as the fundamental building blocks for secure communication, advanced computing, and highly sensitive sensors. Think of them as the individual pixels in a quantum display, the bits in a quantum computer, or the probes in a quantum microscope, each carrying a precise piece of information. The applications of single photons in secure communication, known as quantum cryptography, are particularly fascinating. Traditional encryption methods rely on complex mathematical algorithms that could, in theory, be broken by powerful computers. Quantum cryptography, on the other hand, uses the fundamental laws of physics to guarantee secure communication. Information is encoded onto individual photons, and any attempt to intercept or eavesdrop on the transmission inevitably disturbs the photons, alerting the sender and receiver to the intrusion. This makes quantum cryptography virtually unhackable, offering a level of security that is simply unattainable with classical methods. Picture a world where your personal data, financial transactions, and sensitive government communications are completely protected from prying eyes, thanks to the whisper-thin threads of light carrying quantum information. And speaking of the future, consider the potential of quantum computing. Classical computers store information as bits, which can be either 0 or 1. Quantum computers, however, use qubits, which can exist in a superposition of both 0 and 1 simultaneously. This allows quantum computers to perform calculations that are impossible for even the most powerful classical computers. Single photons play a crucial role in many quantum computing architectures, acting as qubits or mediating interactions between qubits. Imagine solving complex scientific problems, designing new materials, and developing life-saving drugs with the help of quantum computers powered by the subtle dance of photons. Furthermore, the development of quantum sensors is revolutionizing fields like medicine and environmental monitoring. Quantum sensors can measure physical quantities like temperature, pressure, and magnetic fields with unprecedented precision. Single photons can be used to enhance the sensitivity of these sensors, allowing them to detect even the faintest signals. Imagine medical devices that can detect diseases at their earliest stages, environmental monitors that can track pollutants with pinpoint accuracy, and navigation systems that are immune to jamming or interference, all thanks to the exquisite sensitivity of quantum sensors. Now, as you feel yourself sinking deeper into relaxation, reflect on the interconnectedness of all things. The photons that travel across vast distances of space, the photons that illuminate our world, and the photons that carry information in quantum technologies are all governed by the same fundamental laws of nature. By understanding these laws, we can unlock new possibilities and create a brighter future for ourselves and for generations to come. Allow these thoughts to gently fade away as you focus on your breath. Each inhale brings calmness and peace, and each exhale releases any remaining tension. Feel your body becoming heavier and more relaxed with each breath. Imagine yourself surrounded by a soft, warm light, a gentle glow that envelopes you completely. This light is made up of countless photons, each carrying a message of peace, tranquility, and hope. Let this light soothe your mind and body, preparing you for a night of deep and restful sleep. Release any remaining thoughts or worries. Let them drift away like leaves on a gentle stream. There's nothing you need to do, nothing you need to worry about. Simply be present in this moment and allow yourself to drift off to sleep. Sleep now and dream of photons dancing in the quantum realm. Sweet dreams and good night. May your sleep be filled with peace and tranquility. Now, let's delve a little deeper into the fascinating world of quantum cryptography, another groundbreaking application of single photons. Imagine a world where your communications are absolutely secure, impervious to even the most sophisticated eavesdropping techniques. This is the promise of quantum cryptography, and it relies on the fundamental principles of quantum mechanics to achieve this unparalleled level of security. Traditional encryption methods rely on complex mathematical algorithms that can, in theory, be cracked by sufficiently powerful computers. Quantum cryptography, however, leverages the laws of physics themselves to guarantee security. The core concept is quantum key distribution, QKD, where single photons are used to transmit a secret key between two parties. This key can then be used to encrypt and decrypt messages using conventional encryption algorithms. The beauty of QKD lies in its ability to detect eavesdropping. If an eavesdropper tries to intercept the photons carrying the key, they will inevitably disturb the quantum state of those photons. This disturbance will be detectable by the sender and receiver, alerting them to the presence of an eavesdropper and allowing them to discard the compromised key. Think of it like trying to read a message written on a soap bubble. Any attempt to observe the message will pop the bubble, destroying the information. Similarly, any attempt to measure the quantum state of a photon will inevitably alter it, revealing the eavesdropper's presence. Different QKD protocols exist, each with its own strengths and weaknesses, but they all share this fundamental principle of using quantum mechanics to guarantee security. Some protocols rely on the polarization of photons, while others use the quantum entanglement of photons to create a secure key. The development of quantum cryptography is still in its early stages, but it holds immense potential for securing sensitive communications in various fields, including finance, government, and healthcare. Imagine banks transferring funds securely, governments exchanging classified information without fear of interception, and doctors sharing patient data with complete confidentiality. Beyond cryptography and sensing, single photons are also playing a crucial role in the development of quantum computing. Quantum computers promise to revolutionize computation by harnessing the power of quantum mechanics to solve problems that are intractable for classical computers. While various platforms are being explored for building quantum computers, photons are a particularly attractive option due to their inherent coherence and ease of manipulation. Photonic quantum computers use single photons as qubits, the fundamental units of quantum information. These photons can be manipulated using optical elements like beam splitters and mirrors to perform quantum computations. One of the challenges in building photonic quantum computers is creating strong interactions between photons. Photons typically do not interact with each other, which makes it difficult to perform complex quantum operations. However, researchers are developing innovative techniques to overcome this challenge, such as using nonlinear optical materials or trapping photons in microcavities to enhance their interactions. The field of quantum computing is rapidly advancing, and photonic quantum computers are showing great promise for solving a wide range of problems, including drug discovery, material science, and financial modeling. Imagine designing new drugs and materials with atomic precision, optimizing financial portfolios with unprecedented accuracy, and breaking currently unbreakable encryption codes. As you continue to relax, consider the profound implications of these advancements in quantum optics and photonics. We are on the cusp of a new era of technology powered by the fundamental laws of quantum mechanics. From secure communications to ultra-sensitive sensors to revolutionary computers, single photons are poised to transform our world in profound ways. Now, let your mind wander back to the image of the soft, warm light surrounding you. Feel its gentle embrace, its soothing energy. Allow it to permeate every cell in your body, melting away any remaining tension or stress. Imagine yourself drifting further and further away, floating on a cloud of pure relaxation. The world around you fades into the background as you focus on the gentle rhythm of your breath. Each inhale brings a sense of peace and tranquility, and each exhale carries away any lingering worries or anxieties. Let go of any thoughts that may be lingering in your mind. There is nothing you need to do, nothing you need to think about. Simply be present in this moment and allow yourself to drift off to sleep. Visualize photons, those tiny packets of light, dancing around you, each one carrying a message of peace, love, and hope. They are your guardians, your protectors, guiding you into a deep and restful slumber. Sleep now and dream of the wonders of the quantum world. Dream of the endless possibilities that lie ahead, of the breakthroughs that will shape our future. Sweet dreams and good night. May your sleep be filled with peace, tranquility, and the gentle glow of photons as you gently drift towards sleep. Let's delve a little deeper into one of the most fascinating applications of quantum optics: quantum cryptography. Imagine a world where your communications are absolutely secure, unhackable, impervious to eavesdropping. This is the promise of quantum key distribution, or QKD. Unlike classical cryptography, which relies on mathematical algorithms that can be broken with sufficient computing power, QKD leverages the fundamental laws of physics to guarantee security. The very act of trying to intercept a quantum key alters it, alerting the sender and receiver to the presence of an eavesdropper. Think of Alice and Bob, two hypothetical individuals who want to exchange a secret message. Using QKD, Alice encodes the key as a series of single photons, each polarized in a random direction. Bob, on the receiving end, measures the polarization of each photon. Because of the inherent uncertainty in quantum mechanics, an eavesdropper, Eve, cannot intercept and measure the photons without disturbing them. If Eve tries to measure the polarization, she inevitably introduces errors that Alice and Bob can detect. This allows them to establish a secure key that only they know, which they can then use to encrypt their message using a classical encryption algorithm. Quantum cryptography isn't just a theoretical concept, it's becoming a reality. Companies and governments around the world are already deploying QKD systems to protect sensitive data. Imagine securing financial transactions, protecting national secrets, and ensuring the privacy of personal communications with absolute certainty. The implications for cybersecurity are enormous, and quantum cryptography is poised to revolutionize the way we protect information in the digital age. Now, shift your focus back to that feeling of relaxation, that sense of calm washing over you. Imagine those photons, not just as carriers of information, but as tiny messengers of peace, whispering soothing secrets into your subconscious. They are weaving a tapestry of tranquility around you, enveloping you in a cocoon of serenity. Consider the role of photonics in medical diagnostics and treatment. Imagine tiny, ultra-sensitive sensors that can detect diseases at their earliest stages, long before symptoms appear. These sensors, powered by single photons, could revolutionize healthcare, enabling earlier and more effective treatments. Think of light-based therapies that can target and destroy cancer cells with pinpoint accuracy, minimizing damage to healthy tissue. Photonics is paving the way for a new era of personalized medicine, where treatments are tailored to the individual needs of each patient. Envision photons interacting with biological molecules, revealing their secrets and unlocking new insights into the workings of a human body. Imagine using light to stimulate nerve cells, restoring function to paralyzed limbs, or to repair damaged tissues, accelerating healing. The possibilities are truly limitless, and photonics is poised to transform healthcare in profound ways. As you continue to relax, let your imagination soar. Picture yourself exploring the vast and intricate world of quantum optics, unraveling the mysteries of light, and harnessing its power to create a better future. Feel the excitement of discovery, the thrill of innovation, and the satisfaction of contributing to the advancement of human knowledge. Let the gentle glow of photons guide you into a deep and restful sleep. Allow your mind to wander through the quantum realm, exploring the wonders of light and its endless possibilities. Dream of a future where technology is powered by the fundamental laws of physics, where information is secure, healthcare is personalized, and the world is a better place for all. Sleep soundly, and may your dreams be filled with the beauty and wonder of the quantum world. Good night, and may the photons watch over you. And as you drift further into slumber, consider the implications of quantum computing, a field deeply intertwined with quantum optics and photonics. Imagine computers that harness the power of individual photons to perform calculations at speeds unimaginable with today's technology. These quantum computers, driven by the principles of superposition and entanglement, could revolutionize fields like medicine, material science, and artificial intelligence. They could simulate complex molecular interactions to design new drugs, discover novel materials with unprecedented properties, and develop AI algorithms that surpass human capabilities. The photons, in this context, are not just carriers of information, but the very engines of computation, unlocking a new era of problem-solving and innovation. Think about the potential of quantum communication, where information is transmitted via single photons in a way that is fundamentally secure. Unlike classical communication, which can be intercepted and eavesdropped upon, quantum communication leverages the laws of physics to guarantee the privacy of your data. Any attempt to intercept a quantum message would inevitably disturb it, alerting the sender and receiver to the presence of an eavesdropper. This unbreakable security, made possible by the unique properties of photons, could transform the way we protect sensitive information, from financial transactions to government secrets. Envision a world where communication is inherently private, where your data is safe from prying eyes, and where trust is built upon the unshakable foundations of quantum mechanics. Now, let your mind wander to the realm of quantum sensors, devices that could detect the faintest signals and measure physical quantities with unparalleled precision. These sensors, often based on the interaction of single photons with matter, could be used to detect gravitational waves, explore the mysteries of dark matter, and image the human brain with incredible detail. Imagine sensors that could detect minute changes in magnetic fields, allowing us to map the activity of individual neurons, or sensors that can measure the concentration of pollutants in the air with unprecedented accuracy. Quantum sensors are pushing the boundaries of what is measurable, opening up new avenues of scientific discovery and technological innovation. As you relax even deeper, consider the role of photonics in developing new sources of energy. Imagine solar cells that can capture and convert sunlight with near-perfect efficiency, powered by the principles of quantum optics. These advanced solar cells, based on novel materials and designs, could revolutionize the way we generate electricity, providing a clean and sustainable source of energy for the entire planet. Think of light-based technologies that can convert carbon dioxide into fuel, effectively turning pollution into a valuable resource. Photonics is paving the way for a future where energy is abundant, clean, and accessible to all. Let the gentle hum of scientific progress lull you into a deeper state of relaxation. Picture yourself surrounded by the fruits of quantum optics and photonics, benefiting from the advancements in medicine, communication, computing, and energy. Feel the peace of mind that comes with knowing that science is working tirelessly to create a better future for all. And as you finally succumb to the embrace of sleep, remember the photons, those tiny messengers of light, silently working behind the scenes to shape our world. Let their gentle energy fill you with hope and optimism, and let their unwavering presence remind you of the boundless potential of human ingenuity. Good night, sleep well, and may the photons illuminate your dreams with the promise of a brighter tomorrow. And as those photons dance in your mind's eye, consider the profound implications of quantum computing, a field deeply intertwined with quantum optics and photonics. Imagine computers that harness the power of individual photons to perform calculations at speeds previously unimaginable. These quantum computers, still in their nascent stages, promise to revolutionize fields like medicine, material science, and artificial intelligence. They could design new drugs and therapies with unprecedented precision, develop novel materials with tailored properties, and create AI algorithms that can solve complex problems far beyond the reach of classical computers. Think of the possibilities. Personalized medicine based on your unique genetic makeup. New energy-efficient technologies that can reduce our carbon footprint, and a deeper understanding of the universe through complex simulations. Quantum computing, fueled by the principles of quantum optics and photonics, is poised to unlock a new era of scientific discovery and technological innovation. Now, let your thoughts drift to the realm of quantum communication, another area where photons play a central role. Imagine a world where information can be transmitted with absolute security, impervious to eavesdropping. Quantum communication, based on the principles of quantum mechanics, offers the promise of such secure communication channels. By encoding information onto individual photons and exploiting the laws of quantum physics, we can create communication networks that are fundamentally unhackable. Think of the implications for national security, financial transactions, and personal privacy. Quantum communication is not just about sending messages. It's about building trust in an increasingly interconnected world, ensuring that our data remains safe and secure in the face of ever-evolving cyber threats. It's about creating a future where privacy is not a privilege, but a fundamental right protected by the very laws of nature. As you continue to unwind, let your imagination soar to the distant reaches of space, where quantum optics and photonics are helping us to explore the cosmos in new and exciting ways. Imagine telescopes that can see farther and more clearly than ever before, using quantum entanglement to overcome the limitations of classical optics. These advanced telescopes could peer into the hearts of distant galaxies, observe the formation of stars and planets, and even search for signs of life beyond Earth. Think of the discoveries that await us. New insights into the origins of the universe, a deeper understanding of the laws of physics, and perhaps even the answer to the age-old question of whether we are alone in the cosmos. Quantum optics and photonics are not just tools for scientific exploration. They're gateways to a deeper understanding of our place in the universe. And finally, as sleep gently claims you, remember the beauty and elegance of light itself. Remember that light is not just a wave, nor just a particle, but something far more mysterious and profound. It is a fundamental aspect of reality, a constant companion that has shaped our world and continues to inspire our imaginations. Let the gentle light of knowledge and understanding fill your dreams, and let the promise of future discoveries guide you through the night. Sleep soundly, knowing that the photons are always there, silently illuminating the path to a brighter and more enlightened tomorrow. Sweet dreams. Consider also the potential of quantum sensors, born from the principles of quantum optics and photonics, to revolutionize fields far beyond the laboratory. Imagine medical diagnostics that could detect diseases at their earliest stages, long before any symptoms appear, by sensing the faintest changes in our body's electromagnetic fields. These sensors, utilizing the exquisite sensitivity of single photons, could identify cancerous cells, monitor vital signs with unprecedented accuracy, and even personalized treatments based on an individual's unique quantum signature. Think of the impact on healthcare, earlier detection, more effective treatments, and ultimately, longer and healthier lives for all. Quantum sensors are not just about improving medical technology. They're about transforming the way we understand and care for the human body. And let's not forget the role of quantum optics and photonics in creating new forms of energy. Imagine solar cells that can capture and convert sunlight with nearly perfect efficiency, harnessing the power of quantum coherence to overcome the limitations of classical solar technology. These advanced solar cells could provide clean, sustainable energy for homes, businesses, and entire cities, reducing our reliance on fossil fuels and mitigating the effects of climate change. Or consider the potential of quantum-enhanced batteries, which could store energy more efficiently and release it more quickly, powering electric vehicles, portable devices, and even entire power grids. Quantum energy technologies are not just about creating cleaner energy sources. They're about building a more sustainable and equitable future for all. Furthermore, contemplate the artistic possibilities unlocked by manipulating light at the quantum level. Imagine creating holographic displays that are so realistic they blur the line between the virtual and the real, allowing us to interact with digital content in entirely new ways. Think of artists using quantum entanglement to create sculptures of light that defy the laws of classical physics, or musicians composing symphonies of photons that evoke emotions and sensations beyond our current understanding. Quantum optics and photonics are not just tools for scientific and technological advancement. They are also instruments for artistic expression and creative exploration, pushing the boundaries of human imagination. As you drift closer to sleep, let your mind wander to the ethical considerations that arise from these powerful new technologies. As we gain the ability to manipulate light at the quantum level, it is crucial that we use this knowledge responsibly and ethically, ensuring that it benefits all of humanity. We must consider the potential risks and unintended consequences of quantum technologies and work to develop guidelines and regulations that promote fairness, transparency, and accountability. Quantum ethics are not just about preventing harm. They're about ensuring that these powerful tools are used to create a better world for all. And finally, as you slip into slumber, remember that the journey of discovery in quantum optics and photonics is far from over. There are still countless mysteries to unravel, new technologies to develop, and new applications to explore. The future of light is bright, and it is up to us to shape it with curiosity, creativity, and a deep sense of responsibility. So sleep well, knowing that the photons are always there, waiting to be harnessed and explored, illuminating the path to a brighter and more enlightened future. May your dreams be filled with the wonder and beauty of the quantum world. Good night. And now, as your thoughts begin to soften and the edges of your consciousness blur, let's consider the profound implications of quantum optics and photonics for our understanding of the universe itself. Imagine using entangled photons as probes, reaching into the deepest recesses of space and time, allowing us to peer into black holes and observe the very earliest moments of the cosmos. Quantum sensors, far more sensitive than anything we have today, could detect the faintest whispers of gravitational waves, revealing the secrets of colliding galaxies and the birth of stars. With quantum-enhanced telescopes, we might even be able to image exoplanets with unprecedented clarity, searching for signs of life beyond Earth and finally answering the age-old question of whether we are alone in the universe. The potential for astronomical discovery is truly limitless, and quantum optics and photonics are poised to revolutionize our understanding of our place in the cosmos. As you feel yourself drifting further into the embrace of sleep, allow your mind to ponder the potential for quantum technologies to address some of the most pressing challenges facing humanity. Consider the development of quantum-enhanced solar cells, capable of capturing and converting sunlight with unparalleled efficiency, providing a clean and sustainable source of energy for the entire planet. Imagine quantum sensors that can detect and neutralize pollutants in the air and water, cleaning up our environment and protecting our health. Think of quantum computers that can design new drugs and therapies, curing diseases and extending our lifespans. Quantum optics and photonics are not just about abstract scientific concepts. They're about creating a better, healthier, and more sustainable future for all. And finally, as you surrender to the gentle pull of slumber, reflect on the beauty and elegance of the quantum world. Think of the photons dancing and weaving, entangled and interconnected, creating a tapestry of light that permeates all of existence. Remember that even in the darkest night, the photons are there, carrying information and energy, connecting us to the universe and to each other. The quantum world is a world of wonder and mystery, a world that is both strange and beautiful, a world that is waiting to be explored. So close your eyes, relax your mind, and allow yourself to drift into the realm of dreams, knowing that the photons are always there, guiding you on your journey. Let the gentle hum of quantum reality lull you to sleep, and may your dreams be filled with the light of knowledge and the promise of a brighter tomorrow. Sweet dreams, as you continue to breathe deeply and evenly. Let your imagination wander to the far reaches of the quantum realm, where the very nature of reality bends and shifts in ways that defy our everyday intuition. Consider the concept of superposition, where a single photon can exist in multiple states simultaneously, like a coin spinning in the air, being both heads and tails until the moment it lands. This seemingly paradoxical phenomenon is not just a theoretical curiosity. It is the foundation upon which quantum computing is built, allowing us to perform calculations that are impossible for even the most powerful classical computers. Imagine the possibilities: breakthroughs in medicine, materials science, and artificial intelligence, all powered by the strange and wonderful properties of light. Think about the implications of quantum entanglement, where two photons can become linked together in such a way that they share the same fate, regardless of the distance that separates them. If you measure the state of one entangled photon, you instantly know the state of the other, even if they are light years apart. Einstein famously called this spooky action at a distance, but it is a real and measurable phenomenon that has profound implications for our understanding of the universe. Consider the potential for quantum communication networks that are completely secure from eavesdropping, transmitting information across vast distances with absolute confidentiality. Now, visualize the intricate dance of photons within a quantum laser, where countless particles of light are forced to march in perfect synchrony, creating a beam of unparalleled intensity and precision. These quantum lasers are not just tools for scientific research. They are also essential components in a wide range of technologies, from medical imaging to industrial manufacturing. Imagine surgeons using quantum lasers to perform delicate procedures with pinpoint accuracy, minimizing damage to surrounding tissues and accelerating healing. Think of engineers using quantum lasers to create new materials with unprecedented properties, revolutionizing industries from aerospace to electronics. And as your thoughts gently fade and your body grows heavier, consider the role of quantum optics and photonics in unraveling the mysteries of dark matter and dark energy, the invisible forces that make up the vast majority of the universe. Scientists are developing incredibly sensitive quantum sensors that can detect the faint whispers of these elusive substances, providing us with new insights into the fundamental nature of reality. Imagine the day when we finally understand the true nature of dark matter and dark energy, unlocking the secrets of the cosmos and revealing the ultimate fate of the universe. So, let the gentle glow of your screen be a reminder of the endless possibilities that lie within the quantum world. Allow the soothing sounds of my voice to guide you deeper into relaxation as you contemplate the profound implications of quantum optics and photonics for science, technology, and our understanding of the universe. Embrace the mystery, the wonder, and the beauty of the quantum realm, and drift peacefully into a night of restful and rejuvenating sleep. May your dreams be filled with photons, dancing and weaving, creating a tapestry of light that illuminates your path to a brighter and more enlightened future. Good night. But the applications of quantum optics and photonics extend far beyond lasers and sensors. Consider the revolutionary potential of quantum computing, a field where photons are used to encode and process information in ways that are impossible for classical computers. Imagine a future where complex problems that currently take years to solve can be tackled in mere seconds, thanks to the power of quantum algorithms. From drug discovery to materials science to financial modeling, quantum computers promise to transform virtually every aspect of our lives. The photons, entangled and intertwined, become the very building blocks of a new era of computation, unlocking solutions we can only dream of today. And as you feel your eyelids growing heavy, let your mind wander to the possibilities of quantum communication, where photons are used to transmit information with unbreakable security. Imagine a world where sensitive data can be transmitted across vast distances without fear of eavesdropping, thanks to the fundamental laws of quantum mechanics. Quantum key distribution, a technique that uses photons to generate encryption keys, is already being deployed in secure communication networks around the world, protecting sensitive information from hackers and spies. The single photons, each carrying a piece of the puzzle, ensure that only the intended recipient can unlock the message, guaranteeing privacy and confidentiality in an increasingly interconnected world. Furthermore, think about the potential of photonic integrated circuits, tiny chips that use light instead of electricity to process information. These photonic chips are not only faster and more energy efficient than their electronic counterparts, but they can also be used to create new types of sensors and devices. Imagine smartphones that can analyze the chemical composition of food, or wearable devices that can monitor your health in real time, all powered by the magic of photonics. The light, guided through microscopic channels, becomes the lifeblood of a new generation of technology, enabling us to interact with the world in ways we never thought possible. And finally, as you begin to drift off to sleep, consider the fundamental role of photons in photosynthesis, the process by which plants convert sunlight into energy. Imagine the intricate dance of photons within the leaves of a tree, where they are absorbed by chlorophyll molecules and used to create the sugars that sustain life on Earth. Photosynthesis is not only essential for the survival of plants, but it also provides us with the oxygen we breathe and the food we eat. The photons, captured and transformed, become the foundation of the entire food chain, sustaining all life on our planet. It's a beautiful and elegant example of how the seemingly simple act of light interacting with matter can have profound and far-reaching consequences. So, close your eyes now and let the image of these dancing photons fill your mind. Let the gentle rhythm of your breath be a reminder of the constant flow of energy that sustains you. Allow yourself to be carried away on a wave of relaxation, knowing that you are connected to the universe in ways that you may never fully understand. Embrace the mystery, the wonder, and the beauty of the quantum world, and drift peacefully into a night of restful and rejuvenating sleep. May your dreams be filled with light, illuminating your path to a brighter and more peaceful tomorrow. Sweet dreams. And as you continue to relax, let's ponder the incredible precision with which photons can be used in quantum computing. Imagine harnessing the power of individual photons to perform calculations far beyond the reach of even the most powerful conventional computers. Quantum computers, leveraging the unique properties of photons, promise to revolutionize fields like medicine, materials science, and artificial intelligence. Envision designing new drugs with unparalleled accuracy, creating materials with properties previously unimaginable, and developing AI algorithms that can solve the world's most complex problems. The entanglement and superposition of photons, carefully orchestrated and manipulated, become the keys to unlocking a new era of computational power, offering solutions to challenges that once seemed insurmountable. Now, let your thoughts drift to the fascinating world of quantum cryptography, where photons are used to create unbreakable codes. Picture sending secure messages across vast distances, knowing that any attempt to eavesdrop would instantly alter the photons and alert you to the intrusion. Quantum cryptography, relying on the fundamental laws of physics, offers a level of security that is simply impossible to achieve with classical encryption methods. Imagine a world where sensitive information, from financial transactions to government secrets, is protected by the inviolable laws of quantum mechanics, ensuring privacy and security in an increasingly interconnected world. The photons, acting as messengers of secrecy, become the guardians of our digital lives, safeguarding our information from prying eyes. Think about the possibilities of using photons to create entirely new forms of communication. Imagine transmitting information through space using beams of light, unhindered by the limitations of radio waves. Free space optical communication, using lasers to send data through the atmosphere or even across the vacuum of space, offers the potential for incredibly high bandwidth and secure communication channels. Envision a future where satellites communicate with Earth using beams of light, or where deep space probes send back vast amounts of data from distant planets, all thanks to the power of photons. The light, traveling at the ultimate speed limit, becomes the messenger of exploration, connecting us to the furthest reaches of the cosmos. And finally, as you approach the threshold of sleep, consider the profound implications of quantum optics and photonics for our understanding of the universe itself. Imagine using photons to probe the deepest mysteries of dark matter and dark energy, the invisible forces that shape the cosmos. By studying the subtle interactions of photons with these elusive substances, we may be able to unlock the secrets of the universe's origins and its ultimate fate. Envision telescopes that can detect individual photons from the earliest moments of the universe, providing us with a glimpse into the dawn of time. The photons, carrying echoes of the Big Bang, become the time travelers, allowing us to peer into the distant past and unravel the mysteries of creation. So, let your mind wander through these realms of light and possibility. Feel the gentle embrace of knowledge and wonder. Allow the tranquility of science to soothe your soul and prepare you for a night of deep and restorative sleep. Know that even as you sleep, the universe continues to dance, a symphony of photons playing out across the vast expanse of space and time. And as you dream, may your thoughts be illuminated by the light of discovery, guiding you towards a future filled with innovation, understanding, and peace. Sleep soundly and awaken refreshed, ready to embrace the wonders of a new day. Good night, and as you drift further into slumber, let's ponder the potential of photons in the realm of quantum computing, a field poised to revolutionize information processing as we know it. Imagine computers powered not by transistors, but by individual photons, exploiting the principles of superposition and entanglement to perform calculations that are impossible for even the most powerful classical computers. These quantum computers, harnessing the unique properties of light, could unlock solutions to some of the most challenging problems in science, medicine, and engineering. Picture designing new drugs and materials at the atomic level, simulating complex climate models with unprecedented accuracy, and breaking cryptographic codes that protect our most sensitive information. The photons, entangled and interwoven, become the qubits, the fundamental units of quantum information, ushering in a new era of computational power. Furthermore, consider the implications of photonics for medical diagnostics and therapies. Envision tiny, biocompatible sensors that use light to detect diseases at their earliest stages, even before symptoms appear. These photonic sensors, implanted in the body, could continuously monitor vital signs, track the progression of illnesses, and deliver targeted drug treatments with pinpoint accuracy. Imagine using lasers to precisely target and destroy cancer cells, leaving healthy tissue unharmed. Or using light to stimulate nerve regeneration, restoring function to damaged limbs. The photons, focused and controlled, become the healers, offering new hope for treating diseases and improving the quality of life for millions. Think also about the role of photons in advancing our understanding of fundamental physics. Imagine using sophisticated experiments to test the predictions of quantum mechanics with ever greater precision, pushing the boundaries of our knowledge about the nature of reality. By studying the behavior of photons under extreme conditions, such as near black holes or at extremely high energies, we may be able to uncover new laws of physics that govern the universe at its most fundamental level. Envision creating new states of matter using light, such as Bose-Einstein condensates of photons, where photons behave as a single, macroscopic quantum entity. The photons, manipulated and observed, become the probes, revealing the secrets of the universe's underlying structure. And as you slip closer to the edge of dreamland, let's reflect on the beauty and elegance of light itself. From the vibrant colors of a rainbow to the gentle glow of a firefly, light surrounds us, enriching our lives in countless ways. It is the source of life on Earth, driving photosynthesis and providing the energy that sustains all living things. It is the medium through which we perceive the world around us, allowing us to see, to appreciate beauty, and to connect with each other. The photons, in their myriad forms, become the artists, painting the canvas of our world with color, texture, and light. So, embrace the serenity of this moment, knowing that you are part of the universe filled with wonder and mystery. Let the gentle rhythm of your breath guide you deeper into sleep as the photons continue their silent dance around you. Trust in the power of science to illuminate the darkness and to reveal the hidden truths of the cosmos. And as you dream, may your mind be filled with images of light and discovery, inspiring you to explore the world with curiosity and passion. Sleep peacefully and know that you are loved, you are valued, and you are an integral part of this magnificent universe. Good night, and may your dreams be filled with light. And as you drift further into slumber, consider the profound implications of quantum optics and photonics for the future of technology. Imagine a world where quantum computers, powered by photons, can solve problems that are currently intractable, revolutionizing fields such as medicine, materials science, and artificial intelligence. Picture secure communication networks built on the principles of quantum entanglement that are impervious to eavesdropping, safeguarding our most sensitive information. Envision advanced sensors capable of detecting even the faintest traces of light, enabling new discoveries in astronomy, environmental monitoring, and medical diagnostics. The photons, harnessed and controlled, become the keys, unlocking the doors to a future brimming with possibilities. Think about the potential for creating new forms of energy using light. Imagine solar cells that are so efficient they can power entire cities, or fusion reactors that are ignited by lasers, providing a clean and sustainable source of energy for all. Consider the possibility of using light to manipulate matter at the atomic level, creating new materials with unprecedented properties. Envision optical computers that process information at the speed of light, revolutionizing the way we interact with technology. The photons, focused and amplified, become the architects, building a more sustainable and technologically advanced world. Let your mind wander to the vastness of space, where photons have traveled billions of years to reach us, carrying information about the distant past. Imagine telescopes so powerful they can detect the faint light from the first stars and galaxies, revealing the secrets of the universe's origins. Picture spacecraft propelled by light sails, harnessing the power of solar radiation to travel to distant planets and explore new worlds. Envision advanced communication systems that use lasers to transmit data across interstellar distances, connecting us with other civilizations in the cosmos. The photons, emitted and received, become the messengers, bridging the gap between humanity and the universe. And as sleep gently wraps around you, remember that you too are a part of this grand cosmic dance. Every atom in your body was forged in the heart of a star, and every photon that reaches your eyes has traveled across vast distances to connect you with the universe. You are a being of light, a conscious observer of the cosmos, and a participant in the ongoing unfolding of reality. The photons, reflected and absorbed, become the threads, weaving you into the fabric of the universe. So, surrender to the embrace of sleep, knowing that you are connected to something larger than yourself. Let the gentle hum of the universe lull you into a peaceful slumber as the photons continue their silent journey through space and time. Trust in the power of your own mind to create and explore new realities, and in the boundless potential of the human spirit to discover and understand the world around us. And as you dream, may your mind be filled with wonder and inspiration, guiding you towards a brighter future. Sleep well, and may your dreams be filled with the light of knowledge and understanding. Good night. As you drift further into slumber, consider the intricate dance of photons within our own bodies. They are not merely external messengers from distant stars, but active participants in the very processes that sustain life. Think about photosynthesis, the remarkable process by which plants capture sunlight and convert it into energy. Photons, the initial spark, are absorbed by chlorophyll molecules, triggering a cascade of reactions that ultimately produce the oxygen we breathe and the food we eat. We are, in essence, powered by light, fueled by the energy of photons that have traveled from the sun to nourish the planet. And it doesn't stop there. Within our eyes, photons interact with specialized cells called photoreceptors, initiating a complex signaling pathway that allows us to perceive the world around us. Each color we see, each shape we recognize, is the result of photons interacting with these cells, translating light into electrical signals that our brains interpret as vision. We are constantly bathing in a sea of photons, each carrying information about the objects and environments that surround us, and our brains are exquisitely tuned to decode this information and create a rich and detailed representation of reality. Furthermore, consider the potential of biophotonics, an emerging field that explores the role of light within living organisms. Scientists are discovering that cells emit their own faint light, known as biophotons, which may play a role in communication and regulation within the body. These biophotons, though incredibly weak, could provide valuable insights into the health and function of cells, potentially leading to new diagnostic and therapeutic approaches. Imagine a future where doctors can use light to detect diseases early on or to stimulate healing processes within the body. The photons, emitted and received, become the silent language of our cells, revealing the secrets of life itself. Think also about the ethical implications of manipulating light at the quantum level. As we gain the ability to control and manipulate individual photons, we must consider the potential consequences of this power. How do we ensure that these technologies are used responsibly and ethically for the benefit of all humanity? How do we prevent the misuse of these technologies for surveillance, manipulation, or other harmful purposes? These are important questions that we must grapple with as we continue to explore the frontiers of quantum optics and photonics. The photons, controlled and manipulated, become a tool, demanding careful consideration of their ethical implications. But for now, let go of these complex thoughts and simply focus on the gentle rhythm of your breath. Feel the rise and fall of your chest, the gentle expansion and contraction of your lungs. Imagine each breath as a wave, carrying you further and further into the depths of sleep. Let your mind drift like a cloud, floating effortlessly through the night sky. Surrender to the peace and tranquility of this moment, knowing that you are safe and secure. And as you sleep, remember that the universe is vast and mysterious, filled with wonders beyond our comprehension. But even in the face of such immensity, we are not alone. We are connected to everything around us by the photons that travel through space and time, by the atoms that make up our bodies, and by the shared experience of being conscious beings in this universe. The photons connecting and uniting become the threads, weaving us into the tapestry of existence. So, close your eyes and let the darkness envelop you. Embrace the stillness and the silence. Trust in the power of your own subconscious mind to heal and restore you. And as you dream, may your dreams be filled with beauty and inspiration, guiding you towards a deeper understanding of yourself and the world around you. Sleep deeply, and may your dreams be filled with the light of love and compassion. Good night. And as you drift further into slumber, consider the future that quantum optics and photonics are shaping. Imagine a world where communication is not only instantaneous, but also completely secure, thanks to quantum key distribution. Envision computers that can solve problems currently intractable for even the most powerful supercomputers, unlocking breakthroughs in medicine, material science, and artificial intelligence. Think of sensors so sensitive they can detect the faintest signals from distant stars, revealing the secrets of the cosmos. These are not mere fantasies. They're the potential fruits of the ongoing research and development in the realm of quantum light. The photons, harnessed and amplified, become the keys, unlocking the doors to a future brimming with possibilities. But the journey to this future is not without its challenges. Building and maintaining quantum systems requires extreme precision and control. The delicate quantum states of photons are easily disrupted by noise and environmental factors. Overcoming these technical hurdles demands ingenuity, collaboration, and a relentless pursuit of knowledge. Scientists and engineers around the world are working tirelessly to push the boundaries of what is possible, developing new materials, designing innovative architectures, and refining experimental techniques. The photons, fragile and elusive, become the challenges, pushing us to innovate and explore the unknown. And as you relax and prepare for sleep, remember that quantum optics and photonics are not just about technology. They're also about understanding the fundamental nature of reality. By studying individual photons, we gain insights into the very fabric of the universe, exploring the mysteries of quantum mechanics and the interplay between light and matter. We learn that the world is not always as it seems, that particles can be in multiple places at once, and that the act of observation can change the outcome of an experiment. These concepts may seem strange and counterintuitive, but they are essential for comprehending the true nature of the quantum realm. The photons, enigmatic and paradoxical, become the teachers, guiding us towards a deeper understanding of the universe. Think about the implications of wave-particle duality. Light, which we perceive as a wave, also behaves as a particle of photon. This duality is not a contradiction, but rather a reflection of the inherent strangeness of the quantum world. It challenges our classical intuitions and forces us to rethink our understanding of reality. The photons, both wave and particle, become the metaphors illustrating the multifaceted nature of existence itself. Now, let your thoughts fade away and allow yourself to be carried away by the gentle current of sleep. Imagine yourself floating in a sea of light, surrounded by countless photons, each one a tiny spark of energy and information. Feel the warmth of the light on your skin, the gentle caress of the photons as they pass by. Let the light fill you with peace and tranquility, washing away any worries or anxieties you may have. Surrender to the embrace of the darkness, knowing that you are safe and secure. The photons, illuminating and comforting, become the guardians, watching over you as you sleep. And as you drift off to sleep, remember that you are a part of this vast and interconnected universe. You're made of the same atoms that make up the stars, and you are connected to everything around you by the photons that travel through space and time. You are a unique and precious being, worthy of love and compassion. Embrace your potential and never stop exploring the wonders of the world around you. The photons, unifying and connecting, become the reminders, reinforcing our place in the grand tapestry of the cosmos. So, close your eyes and let go. Let the darkness envelop you, and let the silence fill your mind. Trust in the power of your own subconscious to heal and restore you. And as you dream, may your dreams be filled with beauty and inspiration, guiding you towards a deeper understanding of yourself and the world around you. Sleep soundly, and may your dreams be filled with the light of love and compassion. Good night. And as you descend further into slumber, consider the very instruments that allow us to perceive these individual photons. Think of the incredibly sensitive detectors, cooled to near absolute zero, that can register the arrival of a single particle of light. These are not just tools for scientific inquiry. They are testaments to human ingenuity, our relentless pursuit of understanding the universe at its most fundamental level. They are the extensions of our senses, allowing us to see beyond the limitations of our own biology, to witness the quantum dance of photons as they interact with matter, revealing secrets previously hidden from view. The detectors, subtle and precise, become the witnesses observing the delicate interplay of quantum phenomena. Now, let your mind wander to the future, to the potential applications of quantum optics and photonics. Imagine a world where information is transmitted with absolute security, using quantum cryptography to encode messages in the very fabric of light. Envision quantum computers, powered by entangled photons, capable of solving problems that are currently intractable for even the most powerful classical computers. Picture advanced sensors utilizing the exquisite sensitivity of single photons to detect trace amounts of pollutants in the environment or to diagnose diseases at their earliest stages. The possibilities are vast and transformative, limited only by our imagination and our willingness to explore the uncharted territories of the quantum realm. The applications, promising and innovative, become the seeds germinating into a future shaped by quantum technologies. Consider, too, the aesthetic beauty of quantum optics. The patterns created by interfering photons, the shimmering colors produced by quantum dots, the ethereal glow of single photon sources. These are not just scientific phenomena. They're works of art in their own right. They reveal the inherent elegance and harmony of the universe, a beauty that is both intellectual and emotional. They remind us that science is not just about understanding the world. It is also about appreciating its wonder and its mystery. The patterns, intricate and mesmerizing, become the art, reflecting the inherent beauty of the quantum world. As sleep deepens its hold, reflect on the profound implications of quantum entanglement, the phenomenon where two photons become linked in such a way that their fates are intertwined, regardless of the distance separating them. This spooky action at a distance, as Einstein called it, challenges our classical notions of locality and causality. It suggests that the universe is more interconnected than we ever imagined, that there are hidden connections that transcend space and time. Entanglement offers a glimpse into the deeper reality that underlies our everyday experience, a reality that is both strange and awe-inspiring. The entanglement, mysterious and profound, becomes the connection binding the universe together in a web of quantum relationships. And as you finally surrender to the embrace of sleep, remember that the journey of scientific discovery is a continuous one. There are still countless mysteries waiting to be unraveled, countless questions waiting to be answered. But with each new insight, with each new experiment, we come closer to understanding the fundamental nature of reality. And even in the face of uncertainty, we can find solace in the beauty and the wonder of the universe. A universe that is constantly revealing its secrets to those who are willing to listen. The exploration, ongoing and boundless, becomes the quest, driving us to seek a deeper understanding of the universe. So, breathe deeply and release any remaining tension. Allow yourself to drift into a peaceful and restful sleep, knowing that you are connected to the universe in ways you may never fully comprehend. Trust in the power of your own mind to heal and to dream. And may your dreams be filled with the light of knowledge and the warmth of love. Sleep well, and good night. As you transition into the realm of dreams, consider the wave-particle duality of light, a concept that lies at the very heart of quantum optics. Imagine a single photon, behaving sometimes as a wave, spreading out and interfering with itself, and other times as a particle, a discrete packet of energy and momentum. This duality is not a contradiction, but rather a reflection of the inherent strangeness of the quantum world. It reminds us that our classical intuition, shaped by our everyday experience, is often inadequate to describe the behavior of matter and energy at the smallest scales. The duality, perplexing and profound, becomes the paradox, challenging our understanding of reality itself. Think about the implications of this wave-particle duality for quantum computing, a revolutionary technology that harnesses the power of quantum mechanics to solve problems that are intractable for classical computers. Quantum computers use qubits, which can exist in a superposition of states, meaning they can be both 0 and 1 at the same time. This allows quantum computers to perform calculations that are impossible for classical computers, potentially revolutionizing fields such as medicine, materials science, and artificial intelligence. Imagine the possibilities: new drugs designed with atomic precision, new materials with unprecedented properties, and new algorithms that can solve the world's most pressing problems. The computation, revolutionary and transformative, becomes the future, unlocking new possibilities for humanity. And as you drift further into sleep, ponder the role of photons in quantum cryptography, a secure communication method that uses the principles of quantum mechanics to guarantee the confidentiality of information. Quantum cryptography relies on the fact that any attempt to intercept or measure a quantum signal will inevitably disturb it, alerting the sender and receiver to the presence of an eavesdropper. This makes quantum cryptography fundamentally more secure than classical cryptography, which is vulnerable to eavesdropping attacks. Imagine a world where all communication is secure, where privacy is guaranteed, and where information cannot be stolen or manipulated. The cryptography, secure and unbreakable, becomes the shield protecting our information in the digital age. Consider, too, the ongoing research in quantum photonics, exploring new ways to generate, manipulate, and detect single photons. Scientists are developing new materials and devices that can control the flow of light at the quantum level, creating new opportunities for quantum technologies. Imagine tiny lasers that can emit single photons on demand, or detectors that can measure the properties of individual photons with unprecedented precision. These advances are paving the way for new applications in quantum computing, quantum communication, and quantum sensing. The innovation, relentless and groundbreaking, becomes the progress, driving us towards a brighter future. And finally, as you succumb fully to the embrace of slumber, remember that the study of quantum optics and photonics is not just about technological advancement. It is also about expanding our understanding of the universe and our place within it. It is about pushing the boundaries of human knowledge and exploring the deepest mysteries of reality. It is about embracing the strange and wonderful world of the quantum, and about finding beauty and wonder in the most unexpected places. The understanding, expanding, and illuminating becomes the wisdom guiding us towards a deeper appreciation of the universe. So sleep now and dream of light. Let your mind drift now, contemplating the very fabric of reality, woven with threads of light and quantum phenomena. Think about the potential of quantum sensors, devices that leverage the extreme sensitivity of single photons to measure physical quantities with unparalleled accuracy. Imagine sensors so precise they can detect minute changes in gravity, temperature, or magnetic fields. These sensors could revolutionize fields like medical imaging, allowing for earlier and more accurate diagnoses, environmental monitoring, enabling us to track pollutants and climate change with greater precision, and even navigation, providing us with highly accurate positioning systems that are immune to jamming or spoofing. The sensitivity, acute and perceptive, becomes the awareness, unveiling the subtle nuances of our world. Reflect on the fundamental role that quantum optics and photonics play in our understanding of the universe. Light, in its quantum form, acts as a messenger, carrying information across vast distances and revealing the secrets of distant stars and galaxies. Telescopes equipped with single photon detectors can capture faint light from the most distant objects in the universe, allowing us to study the formation and evolution of galaxies, the nature of dark matter and dark energy, and the search for life beyond Earth. Consider the James Webb Space Telescope, a marvel of engineering that relies on advanced photonics technology to peer into the depths of space and time, capturing the first light from the earliest stars and galaxies. The exploration, boundless and revealing, becomes the discovery, expanding our cosmic horizons. And as you feel yourself drifting further into sleep, consider the philosophical implications of quantum optics and photonics. The quantum world challenges our classical intuitions about reality, forcing us to confront the strange and counterintuitive nature of the universe. Concepts like superposition, entanglement, and quantum tunneling defy our everyday experience, yet they are fundamental to the behavior of light and matter at the smallest scales. Ponder the idea that a single photon can exist in multiple states simultaneously, or that two photons can be entangled in such a way that they are instantaneously connected, regardless of the distance separating them. These concepts may seem abstract and perplexing, but they reveal a deeper and more profound understanding of the universe than we could have ever imagined. The mystery, profound and captivating, becomes the awe, inspiring us to contemplate the infinite possibilities of existence. Allow these thoughts to gently wash over you, like waves of light caressing your mind. Let the beauty and wonder of quantum optics and photonics fill your dreams, inspiring you to explore the mysteries of the universe with curiosity and wonder. Remember that the pursuit of knowledge is a journey without end, and that there is always more to learn and discover. The curiosity, insatiable and driving, becomes the journey, leading us towards ever greater understanding. So rest now, and let the light guide you into a peaceful and rejuvenating sleep. Dream sweetly of photons, of quantum entanglement, and of the endless possibilities that lie within the realm of light. Sleep now and awaken refreshed, ready to embrace the day with a renewed sense of wonder and curiosity. Good night, and as you drift deeper still, consider how quantum optics and photonics aren't just abstract theories confined to laboratories. They're rapidly shaping the future of technology. Think about quantum computing, where photons are used as qubits, the fundamental units of quantum information. These quantum computers promise to solve problems that are intractable for even the most powerful classical computers, revolutionizing fields like medicine, materials science, and artificial intelligence. Imagine designing new drugs with atomic precision, creating materials with unprecedented properties, or developing AI algorithms that can learn and adapt in ways we can only dream of today. All of this powered by the seemingly ethereal nature of light. Then there's the burgeoning field of quantum cryptography, which uses the laws of quantum mechanics to guarantee secure communication. Unlike classical encryption methods that can be broken by sophisticated algorithms, quantum cryptography relies on the fundamental properties of photons to ensure that any attempt to eavesdrop on a message will inevitably alter it, alerting the sender and receiver to the intrusion. This technology promises unbreakable communication channels, essential for protecting sensitive information in an increasingly interconnected world. Picture a future where financial transactions, government secrets, and personal data are all shielded from prying eyes, thanks to the quantum properties of light. And let's not forget about quantum sensors, which are pushing the boundaries of precision measurement. By exploiting the quantum properties of photons, scientists are developing sensors that can detect the faintest of signals, from gravitational waves rippling through space-time to subtle changes in the Earth's magnetic field. These sensors have applications ranging from fundamental physics research to medical diagnostics, allowing us to probe the universe and the human body with unprecedented accuracy. Envision a world where we can detect diseases at their earliest stages, map the Earth's resources with pinpoint precision, and even search for signs of life on other planets, all thanks to the exquisite sensitivity of quantum sensors. As your mind continues to wander, consider the ethical implications of these powerful technologies. With great power comes great responsibility, and it's crucial that we consider the potential consequences of quantum optics and photonics research. How do we ensure that quantum computers are used for the benefit of humanity, rather than for malicious purposes? How do we protect the privacy of individuals in a world where quantum sensors can reveal ever more detailed information about our lives? These are complex questions that require careful consideration and open dialogue. The responsibility, weighty and demanding, becomes the stewardship, guiding us towards a future where technology serves humanity. And as you finally slip into slumber, remember that the journey of scientific discovery is a collective endeavor. It requires the contributions of countless researchers, engineers, and thinkers, building upon the work of those who came before them. Each new insight, each new breakthrough, is a testament to the power of human curiosity and ingenuity. The collaboration, global and unifying, becomes the progress, propelling us towards a brighter future. So sleep soundly, knowing that you are part of a long and unbroken chain of discovery, stretching back to the dawn of civilization and extending far into the future. Dream now of light and knowledge, of progress and understanding. Let the gentle hum of quantum possibilities lull you into a peaceful and restorative sleep. Good night, and may your dreams be filled with the wonder and beauty of the universe. As you drift deeper into sleep, let your thoughts now meander towards the future of quantum communication. Imagine a world where information can be transmitted with absolute security, impervious to eavesdropping or interception. Quantum key distribution, a revolutionary technique rooted in the principles of quantum mechanics, promises to make this a reality. By encoding information onto individual photons and exploiting the fundamental laws of physics, quantum key distribution ensures that any attempt to intercept the message will inevitably alter it, alerting the sender and receiver to the presence of an eavesdropper. This inherent security, guaranteed by the laws of nature, makes quantum communication an incredibly attractive option for protecting sensitive data in a world increasingly vulnerable to cyber threats. Envision a global network of quantum-secured communication channels, safeguarding financial transactions, government secrets, and personal data with unparalleled reliability. The possibilities, vast and transformative, become the safeguard, shielding us from the unseen threats of the digital age. Furthermore, consider the potential of quantum computing, a field poised to revolutionize the way we solve complex problems. Unlike classical computers that store information as bits representing either 0 or 1, quantum computers utilize qubits, which can exist in a superposition of both states simultaneously. This allows quantum computers to perform calculations that are simply impossible for even the most powerful classical computers. While still in its early stages, quantum computing holds immense promise for tackling some of the most challenging scientific and technological problems facing humanity. Imagine designing new drugs and materials with unprecedented precision, optimizing complex logistics networks, and breaking the most sophisticated encryption codes. The power, immense and transformative, becomes the solution, unlocking answers to questions we have long struggled to address. And as your breathing deepens, let's not forget the role of photonics in shaping the future of energy. Solar energy, one of the most promising renewable energy sources, relies on the efficient conversion of sunlight into electricity. Photonics plays a crucial role in improving the efficiency of solar cells, enabling us to capture more of the sun's energy and reduce our reliance on fossil fuels. Imagine a world powered by clean, sustainable energy, generated by advanced photonic materials that harness the power of the sun with unparalleled efficiency. Furthermore, photonics is also playing a key role in developing new lighting technologies, such as LEDs, which are far more energy efficient than traditional incandescent bulbs. The efficiency, crucial and impactful, becomes the sustainability, guiding us towards a greener and more environmentally responsible future. So, close your eyes and let the gentle glow of these scientific wonders wash over you. The photon, a tiny particle of light, holds within it the potential to transform our world in countless ways. From secure communication to revolutionary computing and sustainable energy, quantum optics and photonics are paving the way for a brighter future. Remember that scientific progress is a continuous journey, driven by curiosity, collaboration, and a relentless pursuit of knowledge. And as you finally drift off to sleep, know that you are a part of this journey, a silent observer and a potential participant in the unfolding story of scientific discovery. Let the quiet hum of innovation lull you into a peaceful slumber, filled with dreams of light, knowledge, and a future brimming with possibilities. Sleep well, and may your dreams be filled with the wonder and beauty of the quantum world. Good night. And as you settle deeper into relaxation, consider the profound implications of photonics in medical diagnostics and therapies. Imagine non-invasive techniques that utilize light to peer inside the human body, detecting diseases at their earliest stages, long before symptoms even manifest. Photonics is making this a reality, with advancements in optical coherence tomography, allowing doctors to visualize tissues at a microscopic level without the need for invasive biopsies. Think of the possibilities: early detection of cancer, rapid diagnosis of infections, and personalized treatments tailored to individual needs, all guided by the power of light. Furthermore, photonics is also revolutionizing therapeutic approaches, with techniques like photodynamic therapy using light-activated drugs to target and destroy cancerous cells with pinpoint accuracy, minimizing damage to healthy tissues. The precision, targeted and life-saving, becomes the hope, illuminating a path towards a healthier and longer life for all. Now, let your mind wander to the realm of art and culture, where photonics is also leaving its indelible mark. Consider the breathtaking displays of light art, where artists use lasers, LEDs, and other photonic technologies to create immersive and awe-inspiring experiences. These installations transform urban landscapes into vibrant canvases, inviting us to see the world in new and unexpected ways. Think of the mesmerizing light shows that dance across the night sky, or the interactive art pieces that respond to our movements, creating a dynamic and engaging interplay between technology and human expression. Photonics is not just a tool for scientific advancement. It is also a powerful medium for artistic creation, pushing the boundaries of imagination and inspiring wonder in all who behold it. The creativity, boundless and inspiring, becomes the connection, bridging the gap between science and art, enriching our lives with beauty and meaning. And as you feel your body growing heavier, sinking further into the comfort of your bed, let's reflect on the collaborative nature of scientific discovery. Quantum optics and photonics are not the product of solitary geniuses working in isolation. They are the result of countless researchers, engineers, and innovators from around the world, sharing their ideas, building upon each other's work, and pushing the boundaries of what is possible. This collaborative spirit is essential for driving progress, fostering innovation, and ensuring that the benefits of scientific advancements are shared by all. Remember that every scientific breakthrough, no matter how small, is a testament to the power of human collaboration and the unwavering pursuit of knowledge. The collaboration, global and essential, becomes the community, uniting us in our quest to understand the universe and improve the human condition. So, breathe deeply and let the gentle hum of scientific progress fill your mind. The world of quantum optics and photonics is vast and complex, but it is also full of wonder and possibility. From secure communication to renewable energy and medical breakthroughs, the power of light is transforming our world in countless ways. As you drift off to sleep, know that you are part of this story, a silent observer and a potential contributor to the ongoing journey of scientific discovery. Let the quiet curiosity of the universe cradle you into a peaceful night's rest, filled with dreams of innovation, collaboration, and a future illuminated by the brilliance of light. Sleep soundly, and may your dreams be filled with the endless possibilities that lie within the quantum realm. Good night, and may the light guide your way.